Hi guys. So the two big goals that I have every year that I teach pre-calculus, one of them is for you to be able to graph and understand completely how to do transformations, and then the second is trigonometry. So I really feel like um, even later on when you do use a calculator, I want to give you the tools so you could just understand graphs um, without much thought because of your pre-calculus teacher drilling this into you. Okay, so your homework. So I'm going to go over your homework. Okay, and like I said, this is probably going to be the hardest uh, problems on the test, and my homeworks are going to be much easier because I'm kind of remember we were like crawling, and then we were holding up on the sides and walking, and I feel like you guys are kind of taking baby steps, and so we're easing you into transformations. I want to just go over some of these problems. Well, probably all, because I only gave you 8 problems to do. Okay, describes a series of transformations. So the pink, you didn't have a pink one because it wasn't colored, and I don't. Okay, anyways, but pink is the parent function, and these are quadratics, and in the series of transformation, in order for g of x, and okay, describe the series of transformation in order for g of x, and then write the equation of g of x. So gave you the parent function, here's g of x. So what I'm going to do is, there's an easy way to do this, and then there is a way for you to do it every single time. It's going to work every single time. So I'm going to do it every single time because this is an easier problem. Okay, so once again, when in doubt, make a table. I make a table of my parent function, which is f of x equals x squared. And I have a 0, 0, a 1, 1, and then a negative 1, 1, and a 2, 4, and a negative 2, 4. And then I'm going to compare it with this g of x function. I'm going to write it because I'm going to try to, and I'm getting rid of this purple. Man, what is up with the purple? You're green. I like green better. Okay, g of x. And we have to find this equation, and we know it's going to have something with an x being squared because it's a quadratic. So x and g of x. And I'm going to put some corresponding points here. So I see the vertex, and you can get a lot out from the vertex. From the vertex compared to the original vertex, what you can most of the times get out is the add-ins, which are the numbers that you added by, because when you multiply 0, 0 by any number, it turns it into a 0. So you can, in most cases, with the vertex, which is negative 4, 0, we can figure out what things are being added from the parent function to get to g of x. Okay, so from there, well, let's write some more points, and we see clear integers right there and negative 3. And on the test, I will put like labeled clear points where you don't have to, have a what are those little things, magnifying glasses, in order to see if it's actually going through the ends of the square. Okay, negative 5, negative 1. And then I'm going to also, no, no, I don't think so. I don't, I don't think that's going to be a negative, is it? Negative 2, negative 4? No, I don't think that actually works. Okay, so negative 4, 0, negative 3, and maybe negative 2 and negative 4, maybe? I don't think so, because if this is that, then that should go straight through too. Okay, if this is the axis of symmetry, then that should go straight through. So that is, see, once again, like you can't clearly see that that goes through because that doesn't go through. So those are the only points that I can actually use from there. Once again, on the test, or any kind of assessment, those will be clearly labeled. Okay, so from the um, from the vertex, you can figure out. I'm going to use a different color. Where's my hot pink? Okay, I think that's my hot pink. You can figure out that in order to get from 0 to -4, that I had to take x's and I had to subtract 4. I had to subtract 4. Okay. And then if I go ahead and do that, if I subtract 4, I get a new table and I get a -4, 0, and then a -3, 1, and a -5, 1. Okay. So now what's being done to the x, is it's being subtracted by 4. So I'm going to start writing my function here. Okay. So I'm going to open up that function and I'm going to put an x, and x is going to have a -4, but remember x's are complicated. So you need to flip that sign. Bam. Okay. Now, let's compare the y's with these two, from these two. Let me see if my cursor still looks like, where's my cursor? Okay, never mind. Okay, so let's compare the y's over here and over here. Well, actually, not that, but over here to these two. Okay, look what happened to 0. Now, 0 is going to hide all the multiplication. Okay, it's not going to hide the pluses and the minuses, which we called add-ins, but it's going to show the multiplication. And you could clearly see that there was no kinds of vertical translations or multiplications going on, but it was multiplied by a -1. So y's were multiplied by a -1. Okay, and so this entire thing is y. So I'm just going to multiply it by -1. Easy, isn't it? Oh, I love math. Okay, or I want you to start getting into the, my next door neighbor is going to start mowing their lawn. They love to, yeah. You can write it like this. This is a universal function sign. It doesn't, you don't have to add these square, because it already shows that this is a function that involves a exponent of 2. Okay, good job. So here we go with the next one. Okay, the pink is the parent function, and so we can just tell by here and here. We know, we can clearly see. Okay. Oh, it says describe this set of transformations. So moved left 4 and reflection over the x-axis. Okay. Reflected over the x-axis and moved left 4.